time to introduce you to a whole new way of thinking about graphing and the way we define equations. Up until this point, we have defined x and y in terms of each other. Okay, for example, excuse me, y is a function of x. I plug in an x, I get out a y. Just made up the example. Or, then we got a little crazy and we said x is a function of y. Now we're going to say that x is a function of t, y is a function of t. We'll put some parameters on it. Parameters, parametric equations. Okay. I'm going to read it to you, and it's a little wordy, but here we go. F and g are continuous functions of t on an interval. Then the equations x equals f of t and y equals g of t are parametric equations, and t is called the parameter. Often t represents time, not always, but often. Clearly it wouldn't in this situation because we have negative. These equations produce what's called a plane curve because it is in the coordinate plane. Okay, so let's just start with something basic. We're going to fill in the chart below for t, x, and y, where we have t filled in already. We're going to sketch a graph of the parametric equation. Then we're going to write a function or pair of functions that represent the parametric equation. You'll see where this is going in a moment. It's really not that hard at first, so let's just stick with the color we have. And we're going to plug a -2 into the, for t, into the x function. So we're going to have -2 squared and then -1, and that's going to give me 3. And then I'm going to plug in a -1, and that gives me 1 minus 1, so 0. And then we're going to plug in a 0, we get a -1. Plug in a 1, we get 0. We plug in a 2, and we get 3. Notice the symmetry here, and if you're thinking, oh, that's a parabola, I hear you, it is-ish. But that's just the x coordinate. Now, I'd love to come over here and start plotting, but I can't, because I have my x values, I don't have my y values yet. And the t value determines the x, and it determines the y. So I have a parameter for x and a parameter for y. And I have 2 equations to deal with. So -2 goes here, that gives me -4. -1 goes here, it gives me -2. 0 goes here, it gives me 0. 1 goes here, it gives me 2. 2 goes here, it gives me 4. Now I'm ready to plot some points, and I'll use green. Positive 3, positive 3, -4, there it is. 0, -2, -1, 0, 0, 2, and 3, 4. And it is indeed a parabola, but it opens sideways. And I would be very tempted to draw this thing. I'm going to draw it. But I'd be very tempted to draw this thing like I've been drawing parabolas for years and years and just go, hey, let's keep going and keep going. No. We're stuck between a t value of -2 and 2, which restricted this as an endpoint and this as an endpoint. We're done. That is all we get to see for this one. Now, we're going to write a function or pair of functions that represent the parametric equation. And this is going to get a little bit tricky, so bear with me. We have, let's go purple. We have a major decision each time. We have x equals t squared minus 1. I know it's x of t. We're just going to call it x. X equals t squared minus 1. And we also have y equals 2t. So if we wanted this to be a function, traditional function like you learned it in Algebra 1, Math 1, whatever you call it, traditional function would finally say y equals blah, blah, blah. Now, knowing what I just said, that we have y equals function, clearly this is not a function. And that's why we're going to have a pair of functions. But work with me here. So we're going to add 1. Why? Because I said so. And then we're going to get the square root on both sides. And we are going to plus and minus this thing. So t is equal to the square root of x plus 1. So now I have a value, let me rephrase that, an expression for t that I can plug over here, and so y equals 2 times the square root of x plus 1, but wait. It could have been positive, and it was, or it could have been negative, and it was. So these technically, are my 2 functions that represent what I see here. Now, they only work for certain x values. And those x values are going to be from -1, which I couldn't go beyond that anyway, up to +3. So this only works for x values. I should have made my box a little bit bigger. Let's do that. Let's put some more stuff in this box. This is only going to be for x values between -1 and 3. So here's what just happened. We just learned that we don't have to have a traditional function. We don't have to have a traditional, non-traditional function that goes the other way, kind of inverse-like. We could have x defined with t and y defined with t, and then we could, here's the process, isolate the parameter in one of the two pieces, plug it into the other one, and that gives you the function. In this case, it's two functions. It's 2 square root of x plus 1 and -2 square root of x plus 1.